We're going to move on into another topic that is somewhat review, and that is composition of functions. Composition is when we deal with more than two functions, or sometimes deal with a function and itself two or several times. So here I have two sets, and remember how a function is defined. Function is a rule that takes one element from set we call the A, pairs it up with an element in a set we call B. So let's make some pairs here. We'll go pair U together. We'll say U, 3 we'll go with 2, and 1/2 we'll go with 8/9. So here's some rule that pairs one element from A with exactly one element from B. And hopefully by now that's familiar to us. We're comfortable with this notation. Now we're going to compose this with yet another function. So here's a set C. What essentially we have now is we have an element from A going to B, and then this element going to C. So let's continue the path. We'll say -1 goes to -5, about 2 goes to 1/9. Let's say 0 goes to square root of 2, and 8/9 goes to 3. So now we have what is called a composition. We took something from A, paired it with B, and then that value got paired with something in a new set C. So if you remember our notation for functions, we have f of x equals something. So here we say f of 8. F of 8 is -1. But now we're saying that this set is a function. And we're saying this function of -1 is -5. For instance, let's say that this set A is f of x. We plugged in 8, we applied the rule, and we got -1. But now let's say that set B is g of x. It's a different function. And when we follow the path, 8, f of 8 takes us to -1. We now put -1 into this function, and we get -5. So if this is f of x, and this is g of x, this set would be called f of g of x. Because, I did that wrong. That is backwards. This is g of f of x, because we did f first. With compositions, we go inside out when we write the notation. So we started with value 8, plugged it into x, applied the rule f. We got a value -1, put that value into the g function, and finished with -5. Starting with this -5, we plug that into f, we get 0, plug that value into g, and we would get the square root of 2. And we could do that for all the values. This is a composition of functions. This is what it looks like as in picture format, or sometimes this is called set format, where we look at everything in terms of a set. Composition of functions. Here it is a little more formally defined. It is simply taking a function of a function of a function of a function of a function until we run out of functions. There is no limit to the number of functions you can do. You can have f of g of h of I of j of q of r of whatever you want to keep doing. Or you could simply have f of g of x or a of b of t. Instead of using x, you're using a time value. You could have f of x. You could compose a function with itself. There really is no limit to what you can do, provided that everything is defined. Here are some of the more common notations for composition. This is not the word fog, it's simply f of g. Sometimes you see that fog notation, that f of g notation in parentheses with an x to identify what the variable is. The notation that I use and the one that's most commonly used is this notation, f of g of x, where we have all the parentheses. These two notations you typically don't see until you get into higher up courses where you're not going to want to see a lot of parentheses. This notation is especially used once you get beyond calculus into more analysis type courses where you have plenty of other symbols to deal with, so they just don't want to use as many parentheses. This is an older notation. This is the more commonly used notation where you have the multiple parentheses. One thing to notice, we always work inside out. So when you plug something in for x, it does not go into f right away. It goes into whichever one is closest to it. We always work from the inside out. So whatever our value of x is, we plug that into g, and then we take that result, plug that into f. We keep working our way towards the outside. Okay, it's example time. Here I have a function f of x and g of x. First task is to find f of g of 2. And then we'll find g of f of 2. So, we have 2, and we're going to plug that into g. So, find g of 2. G of 2, 2's inside the parentheses, goes into this spot. Looks like g of 2 is 7. Since g of 2 is equal to 7, that result gets plugged into the next function, which is f. And the rule for f says whatever is inside the parentheses gets plugged into this spot. And then we square it and subtract 1. So f of g of 2 is equal to 48. Looking at the next example, g of f of 2. 2 is still inside the parentheses, but now we plug into f first, because that's the function that's closest to the inside. That's the function that's furthest inside, I should say. 2's inside the parentheses. We follow the rule for f. We square that and subtract 1, and we get 3. F of 2 is 3. Now we plug 3 into the next function, which is g. And we're going to get 9. And right away we notice something. Reversing the order of the functions gave us 2 different results. So yes, the order that you do calculations matters. It does matter. Going from one order to another order completely changes the calculations you're doing, which kind of makes sense, because here, if we look at f of g of 2, we did the g function first. We doubled something, added 3, squared it, and then subtracted 1. Changing the order, we start by squaring -1, double, plus 3. So we're doing a completely different set of operations from start to finish. Well, we're doing the same operations, but in a different order. Changing the order of the operations changed the final result. So you have to be very careful with your order. Innermost function first, and then slowly work your way out. Here's another function, f of x. And this says find f of -3. Don't let this cause panic. We simply apply the same function twice. That does not mean take your answer and double it. That is completely wrong. It means find f of -3 and then take that answer and plug it into f again. So we need to start with f of -3. And I'm missing a parenthesis. There we go. F of -3. Plug -3 into f. We get -11. F of -3 is equal to -11. Now we plug -11 into f. And we get -35. F of -3 is -35. And if you're asking yourself, why would you use the same function more than once? This is something that's done oftentimes in computer programming. You just don't type in some lines of code and say, okay, now we're done with that forever. Oftentimes, a program needs to do the same sort of process multiple times. So you reuse that same code over and over and over and over and over and over and over again. Take Super Mario Brothers, for example. Every time you push the A button on the controller, Mario jumps. If you don't reuse code, you would need to have that little code many, many, many times, considering how many times you're going to jump in that game. So your choices are have that code available for every single time Mario is going to jump, or have what's called a routine or a loop where whenever Abe is jumped, we go back to that, oh, we have the code right here. We just reuse what we've already used. Just like here, we're reusing a function multiple times. Well, if you have to jump several times in succession, maybe you got to do 4 jumps right back to back to back to back, you would have, in function speak, you would have f of. And in the programming world, you would have, use this code 4 times right in a row and just keep repeating the same code. And yes, there would be a little different input because you would have a little different set of circumstances on the screen, but the principle is there. We are reusing something multiple times. Here's f of 5. So plug 5 in to f, and we get 13. So now we plug 13 back into f. And we take 1 f away. F of 13 is 37. Now we plug 37 back into f, just reusing that same process. I believe that's 109. And then we're down to 1f, which is going to be 325. If I did those calculations correct. Notice that every time we plug in a value to the function, we lose that function. So here we started with 4. As I plug 5 into the first f, it disappears because that f of 5 turned into a value. Then we plug that value into the next f, or the next function. So now we're looking for f of 13. So basically we're doing this. Do this first. Then do this. We can take it away. Then do this. And then finally do this. At every stage, we lose one function because it's being computed. Another example. We have function f and a function g. F of g of 3 is what we'll start with. Start by plugging 3 into g, and we get 7. And then we plug 7 into f, and we end up with 1/4. Moving on to g of f of 3, we're going to have a problem. F of 3 gives us 1/0. 1/0 cannot be computed. Not every single composition is possible. So we have a situation here where it's undefined. One way works. F of g of 3 works. But g of f of 3, no, does not work. Now that does not mean g of f of anything fails. G of f of, I'll just plug in 0. 0 is easy. This works. F of 0 is negative 1/3. Plug 0 into f, we get negative 1/3. And we can plug negative 1/3 into g. We get negative 2/3 plus 1. If you have negative 2/3 and you add 3/3, you're left with 1/3, or you have 1/3. So many values are possible. I could do g of f of 1, g of f of 1/2, g of f of negative square root of 17, and so on. But I cannot do g of f of 3 because we end up with something that's undefined. Not every single composition will be possible, especially when you have rationals with variable denominators, and also look for square roots that are going to give you negatives on the inside. And we'll look at those a little later on as we continue to move on here. Okay, now it's time for the big important part of composition. Calculating values is fine, but that requires a lot of steps. The goal of composition is to find one function that takes you from the beginning straight to the end. So the way a composition normally works is we have a set A, we pair it with an element in set B, and then we go to the next set C. So just like we started with, we had a function f, we then paired that with the function g, and then we paired that with something at the very end. Let me cycle back to that. Here's sort of what happened. We did f of x, we did g of x, follow the right path here, and then we ended up with g of f of x at the end. So we basically did one set of calculations, a second set of calculations, here we are at the very end. Well, it's going to be to our benefit to find a new function that takes us from here directly to here and skip everything in between. If we did something like a function composed with another function, composed with another function, and another function, and finally an end result, that's going to be a lot of calculating along the way. It would be nice if we had one function that went from here directly to here. That's going to be the power of composition, and that's what this is going to be right here. F of g of x. In other words, find one function that does the work of all of them at once. Find that one shortcut to go from here straight to here. So when I plug a value into that, I don't have to get this middle value, or I don't have to get all these intermediate values. I plug in a value here, I'm taken straight to the end result. So here we go. You'll notice on the practice worksheet from the other day that I put on there, you need to become a master at this material. Now we're going to see if you really did become a master. If not, you need to go back and work on some of those problems. Because from this point forward, I'm going to assume we are all experts. F of g of x. We're going to treat this just like x was a number. Whatever's inside the parentheses gets plugged into g. Well, the nice thing about this is we already know what that result is. If x is inside the parentheses, g of x is equal to x minus 3. That's what this says. That's exactly what this says. So I already know what I'm going to plug into f. I'm going to plug g of x into f. And g of x is x minus 3. And now this is something you saw on the practice worksheet and on the previous video, is how do you deal with expressions? Well, we deal with them the same way we deal with numbers. Whatever's inside the parentheses gets plugged into a spot. This is inside the parentheses. The rule is f. Whatever's inside the parentheses gets plugged into this spot. It gets squared, it gets tripled, and then 1 is subtracted from it. So the rule for f is 3x minus 1, 3x squared minus 1. Whatever's inside the parentheses goes here. It's squared, and 1 is subtracted. And yes, you need to take this all the way to the end. You are not done here. So we're going to finish this up a little bit. F of g of x is going to be 3x squared minus 18x plus 26. That is one function that does the work of everything. That will take us from the beginning straight to the end. Let's test it. Here's how we can test that. Find f of g of, let's just pick an easy number, 1. I'm going to do this without using this. I'm going to pretend this doesn't exist yet. I'm going to find f of g of 1 this way. So I take g of 1, plug it in. 1 minus 3 is negative 2. Let's plug negative 2 into f. Squared is 4, times 3 is 12, minus 1 is 11. Now I'm going to find f of g of 1 using this formula. If I get the same answer twice, we're good. If I get a different answer, well, then something got messed up down here in my work. So let's hope this works. Using the formula that we just found, plug 1 in for x in every spot and see what happens. So we get 3 minus 18 plus 26. Yeah, it checks. This formula is one function that does the work of both of these at once. It lets you go from here straight to here. And this is going to be a powerful concept for you to learn. Taking multiple functions and condensing them down into one function. That is something you also need to become an expert at. Let's look at another one. Here we've got 3 functions. And we're going to find f of g of h of x. Here we go. We start at the innermost function, h of x. F of h of x gets plugged into g. F of g of h of x is x plus 2. Now we plug x plus 2 into g. The rule for g, whatever is inside the parentheses, goes here. Whatever is inside the parentheses goes here. It gets multiplied by 2. And then we subtract 3. And that's going to be 2x plus 1. G of x plus 2. Double it. Double what was inside the parentheses. And then subtract 3 from that answer. So now we have f of 2x plus 1. The rule for f says we square what's inside the parentheses and subtract 1. Square what's inside the parentheses, subtract 1. And we will end up with 2x squared plus 4x, and that's it. 2x squared plus 4x. That is f of g of x. Sorry, f of g of h of x. That's our one formula to go from h all the way to the end in one shot. So instead of having to plug something into here, plug the answer into here, plug the answer into here, nope. Whatever x is, we plug it into here, and we get the end right away. Right away. Before you move on from this section, make sure you look at the practice problems. Make sure you are an expert at this material. Post any questions